This is my Arduino load cell scale. This scale can weigh things, convert them to grams and ounces, and vice versa. And lastly, it can zero things. So you can add a liquid or something else that is hard to weigh without having a bowl. This project uses an LCD screen, an LCD I2C converter, a load cell and a quick scale converter, and an Arduino Nano to read, convert, and display the live weight of an object. The scale begins with the load cell. The load cell used in this project has a maximum capacity of 10 kilograms. The load cell works by setting a variable resistance based on the pressure applied to the load cell. When the load cell bends, it causes resistance in the load cell to change, where the more pressure applied, the more the load cell bends. The less resistance will output, meaning a higher voltage. Next, the load cell sends the output to an I2C compatible analog to digital converter. Then, this value is sent to the Arduino Nano. In the setup of the code, libraries are initialized, inputs are assigned to the switch and button, and an attach interrupt is set for the button. Then, an ISR function is created before the loop. At the start of the loop, a floated value, average, is set to 0, so that it is recalculated in each iteration of the loop. First, a mean average of the load cell reading is retrieved with a for loop, where there are 10 iterations, and each time the scale reading is added to average. Then, the average is divided by 10 to calculate the mean. This is done to remove noise in the reading. Next, a previously set floated value, last average, is set to average. This value is keyed to the 0 feature in this project. Next, another previously set value, set 0, is subtracted from the average. Before setup, the value set 0 is set to the weight of the plate on the load cell. This means that it automatically subtracts the plate weight from the reading so that it will read 0 when the scale is first turned on. Since the scale has a lot of noise, I wanted to clean up the noise as much as I could, especially when the scale was reading 0 grams. So I removed any deviation in the readings near 0 grams. Unfortunately, this means that any weight below 0.3 grams won't be recognized on the LCD screen. Then, the attach interrupt statement is used, where triggered is set to false, then set 0 is set to last average. This is extremely important. When the attach interrupt is triggered, it means that someone pressed the 0 button, meaning that they want the scale to 0 the weight. So, since the last average was assigned to average, if you assign set 0 to last average, you are essentially subtracting average from average, making it 0. However, there are many reasons why you cannot just assign set 0 to the average. First, attach interrupt is a feature that, when activated, will trigger a function no matter where you are in the code. Since average is set to 0 at the start of each loop, if the attach interrupt is activated before average has been calculated, the 0 value will not be accurate. Also, you can't just remove attach interrupt, because if you use an if statement to determine when the button is high, you'll have to hold the button to make sure it doesn't skip over the trigger, which is inefficient, or else it'll just skip right over it and move on to the following code. Lastly, the reading value is converted to grams or ounces and printed out depending on the state of this switch, with this if-else statement. Lastly, here's a close-up view of the PCB case I designed in Fusion. In the interior, the PCB on the right connects the LCD backpack to the LCD.